I've been working with aggregate intellect for this open source project and also other kinds of projects for a while. And I'm currently a PhD student at McGill University. And basically, in my day-to-day research life, I try to break large language models, and graph networks, and all kinds of neural networks. Basically, try to break them and find what are the problems that we are facing with those models. And in my work with aggregate intellect, I basically try to fix the problems and issues I find during my research with this practical usage. So basically, today I'll talk a bit on this Sherpa project, and essentially, recently I have been focusing on setting up a nice testing framework for the Sherpa, especially on GitHub, and since to enable basic collaboration between more people and newcomers joining this project. So I'll talk a bit about the Sherpa project itself, and then we'll basically have more like a roadmap about how we can, from the beginning where we didn't really have a lot of tests and the test breaks and so on, to the current stage where we have I'm not saying that like a very good way, but like, I mean, a reasonable way of testing the things and keeping things running, and able to perform some sort of continuous integration. So just to say, like, this is probably not the best way of doing the test, and maybe there are better ways to do it. So if you have any thoughts, or you have also doing the same thing but through a different path, just leave some comments in the chat, and we can have a nice discussion about it, I think. So just a bit more context about what Sherpa is doing, right? So the initial idea, like Sherpa starts really from this Slack bot that Amir mentioned, but now we're basically extending Sherpa to a bit more than that. So basically a multi-agent framework where we can have human to interact with it. So as you can see, currently in the Slack channel, you can ask Sherpa some questions, and you can respond to Sherpa with some more information. Sherpa will correct the response, or hopefully will provide some more information that you want. So currently in the Slack, that Sherpa only has this question answering agent that tries to answer a question that you ask to it. But what we are building on is basically a multi-agent framework that there will be analyzed, there will be researcher doing different types of tasks, depend on what kind of task you ask it. Of course, rely on different types of tools and different types of external data coming in order to answer this question. So you can already say here that, of course, the entire system is built on large language model, but the large language model is not the only thing, right? There are different types, like different APIs that we connect to, like Google search, like vector database, different types of data where we handle mostly text, website, and the files, and so on. So really, in this case, the large language model is, of course, the heart of the system, but there are a lot of things building around it, and we want basically to test those functionality as well, right? So before we go into details, so I just would like to say that there are a lot of people like me that are contributing to this open source project, and of course, if you're interested in, and feel free to basically post the message, or just we'll have a slide for that with some starting point that you can start, and at the end, basically we want you, so feel free to join if you would like to. Okay, so the testing problem. So what do we have is we have this Sherpa application, which at the heart of it is this large model, of course. Currently, we rely on OpenAI API a lot, and we're trying to support different kinds of open source models as well. So the large model itself is not really the entire thing of the application, but we have a lot of code, other types of functional code that we want to, like, more or less entangle, disentangled with large model that we want to test. So basically, the types of things that we want to test against are basically, we want the entire system to kind of work no matter if the large model gives us garbage or nice thing, right? If the large model gives us reasonable answer, we should be able to process it. For example, include some links to the references and give it back to the user. But even if it outputs some garbage, we probably still want the system to work in the sense that either notify the user, okay, something happened, please try again, or something like just take whatever, that's it, and try to process, so the system will not break from this aspect. And also say, like, OpenAI does this like regular update several times a year, and we want to kind of make sure, okay, what might be the impact of this update from OpenAI would bring to Sherpa, right? If we rely on Sherpa, like the OpenAI APIs, like if it improves the performance, you can make some changes, include some more. If the new update from OpenAI will make the GPT to tend to include more links or less links, tend to include more bullet points or less bullet points, we want to kind of observe that some potential impact from the changes of OpenAI. And as you can see, since we are building a multi-agent framework, there are a lot of complex interactions between the agents and their different actions. So it's not like we just call the LLM once and that's enough, right? So typically we have like sequential LLM calls that kind of depend on each other. That's the third thing that we're considering. And the last thing is, of course, we're using OpenAI API, and we need to consider the money that we spend, right? If we're actually doing answer questions and so on, that's another story. But if we're doing testing, we don't want to like every time we're doing some testing, we need to keep the OpenAI calls and cost some money. So that's something we also want to avoid. So another thing that I want to mention here is that we kind of like separate the problem of LLM evaluation and testing, software testing for the application, right? So I'm pretty sure that LLM evaluation, we already had 3 talks about it, and we'll have more talks about LLM evaluation throughout the day afterwards. So in LLM evaluation, we try to evaluate the response from LLM, like for example, it answers question correctly, or it has enough diversity in output that it gives more or less creative results every time. And in our problem, we kind of say assuming, okay, we have this OpenAI API, which is a great LLM, maybe, and we're assuming that we have reasonable kind of prompt, and want to make sure the rest of the system would work as expected. And the types of thing is, for example, we know that I have an idea that what kind of prompt we want to give, and the kind of thing we want to test is like the prompt that we give to the large language model is as expected, right? For example, normally we build prompt automatically from a template. I want to make sure that the template, after we fill the information, is whatever the prompt that I'm expecting. And also that the behavior of the application after the LLM output something would also be whatever we expected. So the difference would more like in the LLM evaluation, have the test data sets or some sort of test that we try to evaluate the general performance or like matrix accuracy, precision, and so on this data set. And in our case, we have some expected behavior and properties of Sherpa that we want to satisfy, and we try to test that they are actually unsatisfied. So here we more focus on the system testing or application functional testing side. So since we're talking about software testing, so I have to bring a bit on the conceptual stuff that different levels of testing we have in the software. And typically we have 4 levels of software testing, as probably a lot of you know, like unit testing, which is at the most fine-grained level that we just test a particular functionality in the system. Like for example, generate the prompt, right? Fill out the template with the information and generate a prompt. Or the acceptance testing, where we actually just have a list of things. For example, this is more like create like a test set for the entire system. Like for example, questions, and we have the target answer, and we try to generate target answer from the example questions. And today we focus more on the first 2, which is the unit testing and the integration testing. As you can see, in this case, we have something that the LLM may not fully involved in these testing stages, where in system testing, acceptance testing, that we want the LLMs to be involved for sure. But in unit testing, the first thing we can do is we can try to disentangle, try to fill out like as much features, as many features as possible that we don't need LLM for it, and then we test it on its own, right? But for the features that we cannot really, it really relies on output of LLM, that's something we'll handle, and also that's the same thing for integration testing as well. Right. So basically, based on the testing level, assuming that we have some features that we really need LLM's participation, right? It's not like something that we can just test on its own. We really need outputs, inputs to a larger model in order to test the functionality. So this can be a post-processing. For example, in your case, it can be a post-processing module that tries to add citations to the output of the larger model based on the input documents. In this case, we really need true output from a larger model, and we cannot separate it because it relies on that particular component. So in this case, what types of things that we want to test in this particular unit functionality is, for example, we have the prompt that we should test the prompt template. We should make sure that the input parsing works correctly. And when we test the output of a larger model, normally we can test, say, like if the output satisfies some sort of property, which is a checklist that I'll bring a little bit more in the next slide. And we can also test like output parsing works properly for normal cases where the larger model gives us unexpected results, or surprising cases where the larger model gives us a more kind of surprising result. So in the unit testing, if we just test the larger model alone, normally we can do some sort of checklist where we say that the output of the larger model does whatever we expected, right? So this is basically based on another paper that it's used for testing general NLP models. But this is something that we can borrow back to this larger model paradigm as well, that we can have some test cases. For example, we have a larger model that tries to test tries to do like some sort of sentiment analysis. Then we can basically give a list of sentiment analysis modules and some sentences. We make sure that we know that they are negative and we can include those tests in the test cases and make sure the large model gives us the negative result, for example. So this is how we select the input to the unit test and then try to make sure the entire system kind of follows the same flow. And when we go into integration testing, it will be more interesting, right? Because then we can actually test the behavior of the components in more large language model. Like in case that of the Sherpa the chatbot that we're building, or multi-agent workflow chatbot that we're building, is that it's really hard. First, it's really hard to evaluate that if the question is correct. So that's more like a large model evaluation question, because the quality of the outputs more or less depends on the larger model. But in this case, what we can make sure is some additional feature that's less dependent on the larger model. For example, the resource citation, where we have post-processing frameworks try to add the resource citation. So that's something we can check, make sure there is no that the resources are valid. For example, if you have a post-processing to generate resources, you can make sure the links are the links that you gave in at the beginning, or if you have the large model to generate the links, you should check that the links are actually valid, for example, and those sort of things. And you can also check that there is no harmful content, for example, in the test cases, and you can flag to make sure that those are probably something that should include in the prompts, and if you don't include in the prompts, they may provide potential harmful content, and you can catch that with the test cases. So it really depends on, so up to this integration testing part, it really depends on your use case. And basically, in this case, you test with respect to your use case. So if you have a math solver, you can provide, like it's even easier because you can provide some math equations and make sure that those things can be solved correctly. And if you have a code generator, you can make sure the code compiles and so on. So those are things in the integration testing, you really make sure that you're testing against your use case of those components. So finally, the thing that we'll consider is the determinism, which I think is more or less the biggest challenge that we face when we are considering the testing for Sherpa. Which is, we know that, of course, the results for large model varies for each call, like by default. Of course, we can And we don't really know. So if we just use the default setting of large model and we have some test failed, it's really hard for us to know that if the test failure is due to a defect in the code or just the large model is unfortunately giving not a very good result in this case. So essentially, we basically, based on that, we separate our test runs into two categories. One is frequent test runs, where we want it to be as deterministic as possible, and basically try to make sure, meaning in this case, we want to test the functionality, we want to test the code around the larger model, itself, right? And in between the frequent test runs, we will have some infrequent test runs that by itself can be indeterministic if we want diversity. We give a higher temperature, and we test the behavior of basically test the behavior entire application plus the element. We can do this testing, but those are less often because most of the time we make some change to code, to the functionality, to the parts, to the post-processing, to the input processing. The large model want to make sure the code actually works. We are less care about the large model's performance in this case. And like sometimes, like every sometime, we will need to test the entire system because there may be a change from OpenAI, or we have aggregated enough small changes in the code where the entire system may behave differently. So that's the infrequent test runs. So then basically the infrequent test runs are very easy, right? In your case, we just test the system as is, hit the OpenAI API, and that's it. But if you want to have a deterministic test result, how can I do that? Of course, if we are using OpenAI API, we can set temperature to 0. If we are running the model locally, we can control the random seed for the generation. And I think recently OpenAI API also has this seed parameter, but it's still in beta, so it's not a guarantee that the output will be deterministic. Of course, that's what you can do is basically mock testing and caching the result of large model. And this is basically the way we select it. And of course, one of the very big reasons you can say is it saves money. That we run only hit the OpenAI API during the infrequent runs, and then we try to mock the behavior of large model during the frequent runs, so that we don't need to hit the OpenAI API every time we do have a pull request and when we try to do continuous integration. So basically, if you're not familiar with mock testing, the mocks is basically a concept in software testing where we have these mocks that it simulates the behavior of the component. So we are not actually testing the component or hit the component itself, but we try to simulate its behavior. And in this case, the component we want to mock is the larger model. So basically, you have an idea what are we testing if we mock the large model, right? Because the rest of the system can depend on it. But here we also have very important things we can test even if we mock the large model itself. We can test the input processing, output processing, as I mentioned, a number of times so far. There are also interesting things since our system, as I mentioned before, depends on this complex chain of almost like chain of thought or React system basically has a lot of different large model calls depend on each other. So we can actually also make sure that the number of calls or the sequence of large model calls is whatever we expected as well by mocking the large model. And there are different ways to mock it. One is we can just create the most ideal output for large model manually, which can be very time consuming. And the other way is we can actually record larger models output. And another challenge in what you deal here is that we have these infrequent test runs and frequent test runs, and we don't want to write a lot of different tests. We don't want to write one test case for the test where we mock the large model and one test case for the case where we hit the OpenAI API. We kind of only want to have one test case where we can have some options where during the infrequent test runs, we just mock the larger model, and during the frequent test runs, we hit the OpenAI API. So basically, that's the case of the Sherpa where we ended up after we have all those long discussion from the previous slides that you have seen. So in the Sherpa, what we have is we have a lot of components based on the large model, as I presented at the beginning of the presentation. We have frequent updates to the code base because we have a lot of people working on it. So previously we didn't do any testing, and we see a lot of failures after some PRs are merged, and we have to do this emergency patching to those bugs that introduced by PRs. So we decided, okay, now we have to think about testing. Previously, we have a lot of existing testings that's based on OpenAI logic models, and that's the thing that we said we more or less have these infrequent test runs already written on, and I don't want to write new test cases just for mocking. We just want to reuse those test cases as much as possible and save money, of course, as well. So basically, the solution we did was to unify the mock testing and the real testing. So unify the frequent and infrequent tests at the same time. So the target is for us to reuse the test cases already written, depends on the OpenAI API as much as possible. And at the end of the day, we have two modes of running the same test. So basically, we will have infrequent test runs at the beginning, which actually keeps the OpenAI API. And we created this large language model with caching mechanism where every time it hits the OpenAI API large model or whatever, any kind of large model, actual large language model, it will cache the input and output response for that call automatically based on the name and based on some properties of the test, so that we can identify the particular test case. And when we do the frequent test runs where we want to mock the larger model, we'll automatically load those caches for the large model and reuse the responses from previous tests for the frequent runs. So basically, we have the caches indexed by the test cases names. Then we have the fake large model, and it's actually the fake LLM from Longchain that basically will load the cached test, and what it does is that it ignores whatever input by the from the calls to the large model, and it outputs the loaded output by sequentially from the cache. So basically, we're assuming that, and actually it's not an assumption, it's a requirement that once the large model call sequence is always the same if we have the same output. So there's most of the time no indeterminism if we have the same output from the larger model. So as you can see here is one example of the caching that we created. So the files are basically indexed by the test file name and the test case name, and so that we can automatically load it if we run the test in the mock mode. And we have some inputs, as you can see, some descriptions that basically the prompt after we fill out the template. We will also have the output. Basically, that's the result for the output from the large model. I will also record the part of them that we used so that we can distinguish like the output from different large models, and we can also compare them. And lastly, we also version control this on GitHub. Version control those caches so that we will be able to check if OpenAI has made some changes on their side. We'll be able to check what is the changes in our case and what might potential impact by just inspecting the differences between these two texts. Of course, in this case, GitHub didn't really have a very good way to compare the two, but you can use other types of differential comparison text differences to compare what are the differences after if you're switching from OpenAI model to an open source model, or if OpenAI made some changes to their models as well. Yeah, so basically this concludes the journey from at the beginning, where we have started to think about this problem and think about it in a more software testing kind of setting. So until now, that I basically have a way of running the mock testing frequently, and basically every time when people want to make a PR, we will run the frequent testing, and basically uses the caches, and we only generate the caches once. Currently, we haven't yet run another type of the infrequent testing again, but we just generated once, and maybe there are some other features use this judgment model. Will generate the caches for those tests as well, and basically finally we basically index them on GitHub so that we can version control them and basically check if there's a changes in those files. That means either there's some changes in the prompt, or because then the prompt changes, the output will change, or there will be some changes from OpenAI side. Then we'll be able to make sure that something has happened, and those things are what we are expecting. So before I check if there are any questions, so here we have some other active features that we're actively working on in Sherpa, and I actually highlighted some of the things that potentially I think can be interesting. So we have a lot of issues that you can actually go and say in the GitHub repository to say if there are different controls on Sherpa workflow. The things that we're working on, we are trying to build a command line interface for Sherpa as well. Like currently it only works with Slack, and we are aware that for some people it may not very convenient to actually set up all those Slack accounts and Slack apps. So we're trying to build a command line interface so that we can directly interact with Sherpa. So we'll also build a lot of different tools like Q&As for Hugging Face using the Hugging Chat. And we're also working on, so now we have this test set up. Next step is actually build the GitHub action for continuous integration on each action, on each PRs. So yeah, if you are interested, definitely check out this link and check out some onboarding checklist, and feel free to join the regular meeting that we have weekly as well. Right, so at the end, lastly, I think I will introduce Amir to talk a little more about how actually you have some version of Sherpa. So you have seen this Sherpa takes you to top of Mount Everest, but we actually have some Sherpa that takes you to the moon that's even higher. So I'll let Amir talk more about it.
Thank you, Percy, for the presentation. Yeah, we're going to have a bit of a discussion about it, but just to use this opportunity to plug in, what we are doing on the commercial side. So what Percy presented here is the open source project. There are multiple links in the chat that you can learn more about it. There's an onboarding checklist. There's the GitHub issues link, and a link to the testing suite that Ash put in the chat, as well as the weekly meetings. All of these are in the chat, so please take a look at them and see if you're interested. And we are looking for more contributors to the open source project. Sherpa is largely an open source project, and any work that you do in this project will be released in the same repo under MIT license. So that's a very commercially viable way of contributing to some interesting project. As Percy showed at the beginning, the big picture about Sherpa is this multi-agent system that we want to use to help the small to medium-sized service businesses leverage these types of technologies. There is a lot going on in big enterprises using these kind of technologies, but our mission is really helping smaller players who have been running very interesting knowledge-based businesses like consulting services and such, who don't have access to those kind of sophisticated teams that builds all sorts of custom things. So our goal is to use some expanded version of Sherpa to help these types of businesses also leverage these types of technologies so that they can stay competitive and don't become, more blockbusters. So if you know anybody who works in any types of business that can leverage generative AI technology like what you saw today, pass them this link to book me or book me yourself if you want to talk about it.